A light-dependent resistor is a component that changes its resistance as the intensity of light directed at it changes. Here's what a light-dependent resistor would look like. This wavy conductor at the top acts as a sensor, which reacts when light is directed at it. In particular, its resistance changes as a result of releasing more charge carriers, though you won't need to know the details of what causes the change in resistance at GCSE. But you do need to know that the light-dependent resistor has this circuit symbol. The rectangle in the circle shows it's a type of resistor, and these two arrows show that it is reacting to light. Also be aware that we often abbreviate light-dependent resistor as LDR. So how does the resistance of the LDR change? Well, the resistance of the LDR decreases as the light intensity increases. Let's see how this would work on an IV graph. Remember that we plot the potential difference across the LDR on the horizontal axis against the current through it on the vertical axis. First, we can plot this line for when the LDR is in dim conditions and there's not much light. Notice that this is a straight line through the origin, showing that when the light isn't changing, the LDR acts as an ohmic conductor with constant resistance. But then if we change the light intensity, for example by shining a torch onto the LDR, we would get a different straight line for these new bright conditions. Both graphs are straight lines. All that's changed is how steep they are. Remember that the gradient of an IV graph tells us the resistance of the component, and components with less resistance will have steeper graphs. So here, since the graph is shallow for the dim light, the LDR has high resistance. Then when we increase light intensity to the bright conditions, we get a steeper graph, so there is a lower resistance. So that's how the resistance of an LDR changes. But where would we see this component used? LDRs are useful in circuits that need to react to changes in light intensity. For example, we would only want a security light to activate when it is dark and extra light is needed. So an LDR is used to measure how bright its surroundings are and adjust the resistance and current in its circuit accordingly. Also, most smartphone screens are designed to automatically adjust their brightness, depending on how bright their surroundings are. An LDR in the phone detects this light intensity and adjusts the current and power given to the screen. For your exams, you won't need to recall these exact examples, but you could be asked to explain why an LDR might be useful for a given device.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!